Yes, good afternoon, guys. I've taken the liberty to try to solve one of the problems that you had problems with. That was problem number 10. It said, you were given a revenue function r of x equal 30x minus 0.02 x squared, and then a cost function which was given as 2x plus 5. That was the cost function. So we were supposed to find the profit maximizing output of the firm given this revenue and given this cost function. The only thing we need to remember here is how to take the derivative of a function. Remember, and in this case, we only need the power rule. And so the question is, what is the power rule and how do we apply that? The power rule states that if you have a function, say f of x equal to some constant, this can be 1, 2, 3, whatever, times x, so some constant x raised to the power n, then the derivative of such a function, f prime of x, will be equal to the constant times the power x raised to the power n minus 1. So, for example, if I have some function f of x is equal to, say, 3x to the power 2, then the derivative of this is going to be equal to 6x to the power 1, or simply 6x. If it's a constant, if it's just, say, if f of x is equal to, say, 10, the derivative of this is going to be equal to 0. The derivative is going to be equal to 0 because there's no x here. Remember, derivatives are about what? Slopes, basically. So the derivative here is going to be equal to 0. So here, f prime of x will be equal to 0. That's just by the way. So this thing, how do we solve a problem here? We need to set, again, you set the marginal revenue equal marginal cost and solve for x. So remember, in the revenue function, x is simply the number of units the company was able to sell. In the cost function, x is simply the number of units that the company was able to produce. Therefore, to solve this, we need to apply the power rule to the revenue function. And if we do that for the first part, for that first part, then the derivative of that is going to be equal to what? The derivative of that is simply going to be equal to 30. The second portion, this side, the derivative, how do we find the derivative again? Is this x raised to the power 2, multiply this by that. So we are going to get minus 0.04 and subtract 1 from that exponent. So you end up with what? X again. So set this equal to marginal cost. Marginal cost here is going to be 2 plus 0, because this is a constant. The derivative of a constant is going to be equal to 0. The derivative, let's say y is equal to 5. What is the slope of such a function? Well, is 0. If you just have y equals to 5, there's no slope. It's just some constant. So at this point, we can solve for the profit maximizing output. I mean, we have this, we have that, so we have the marginal revenue, we have marginal cost. So simply reorganize this, rearrange this like terms on one side. We are going to have 0.04x is equal to what? Subtract 30 from both sides. You are going to get 2 minus 30. So we are going to get minus 0.04 is x is equal to minus 28. So we can divide through by minus 0.04, divide through by minus 0.04, and we are going to get x is equal to what? 700. So the profit maximizing output here is going to be what? 700. And how do you do that? If you have a revenue function, if you have a cost function, set them equal to, set the marginals equal, the margins equal to each other, and solve for x, and that is your profit maximizing output. So here, if this is a perfect right now we are talking about perfect competition. If you are a profit maximizing firm under perfect competition, basically this is what you are supposed to do. Thank you very much. I'm going to make another short video so that you don't have to sit and listen to everything at once. All right. So the next video, I'm going to solve under monopolistic competition. What am I going to do? I'm going to try to solve one problem similar to this, and then we'll leave it at that for this week. Okay.